Alrighty, folks. Happy April. It is April still, right? Yeah. Welcome back to Central. We are very appreciative to Central for having us here at Central Insurance. And this month we have my good friend Barret Blake talking to us about Entity Framework. Entity Framework is one of those things I always wish I knew better. And there's definitely some gotchas out there. So Barret's going to be sort of demystifying some of that for us. Before I get this off the screen, we do have a Discord group that you can join. I was smart and this time generated a permanent link instead of one that expires after 7 days. Lessons learned there. But we have a beginnings of a group there, so if you have ideas or job posts or anything like that you want to post there, have at it. We are on Meetup. We meet the fourth Thursday of every month until October. We are always fallow in November and December. Just because that's usually some collisions with other events during those times. I think, Barret, you were our last talk last year, if I'm remembering. I think you were our October talk last year, maybe August, but
somewhere there.
Yeah, it's good to have you back. Organizers are Alan, myself, and Sam. Sam came down with something, so he's shielding you all from himself tonight. But if you're interested in helping us, just chat with us. We'd love to hear how you want to help. And we'll connect you. YouTube, hello YouTube. You can join live if you're ever not able to come here and enjoy our nice free pizza. Or you can take a look at some of our past talks out there as we both live stream and we post the recordings as well. Discord, I mentioned that as well. So here's your QR code if you want a nice scannable thing. We just have a few baby channels out there. Where's Phil? Phil, this is your idea, just a way of kind of coordinating between months and just seeing what we can do to keep people connected, and then maybe last minute announcements can go in there as well as Meetup, because it's not always easy to get those notifications. We are still on Twitter, which would you call it pronouns for corporations instead of X?
Pronouns for tech companies.
Yeah, that's an interesting one. It'll stick with me a little bit. And we have a LinkedIn group that we don't use very much, but you can. So if you have a hiring need, if you're looking for work, you can post that LinkedIn group. It is a private group, so you do have to get approved to go in there, but it should auto-approve you if you are a developer title. Otherwise, one of us just clicks accept when we see you, which is usually pretty quick. Sponsors, thanks to Central for your lovely space and pizza. Thanks to .NET Foundation for paying our dues on Meetup. We really appreciate that. Leading Edge is not a sponsor, but I forgot to update the slides from last month. They hosted us as a kind of a fallback last month. JetBrains is giving us our coupons for Writer and ReSharper and things like that. Speaking of JetBrains, WebStorm and Writer are still free. They made this change a bit ago now at this point, but if you're using them non-commercially, they are free. If you want to use them commercially, if you want to have a free license, raise your hand. All right, you are our winner for the month. We're not going to do a raffle. You are our license, so I'll chat with you later. Woo! This is a pretty slow hand raise, but you still won. Okay, cool. I'm wearing my lovely Star Trek shirt, which is sadly not in Papyrus. It looks a whole lot like Papyrus, but I'm told it's not technically Papyrus. Star Trek is next Friday. Show of hands, who's attending? That is a lot of people. That's awesome. So this year we're trying something new. So if you're not familiar with Star Trek, we are a one-day conference that takes place at AMC Easton the first Friday of May every year since 2009. It's a lot of fun, and this year we have kind of shrunk the size of each presentation, the time length, so we can fit in more content. So we have a ton of content, including Barret, myself, anybody else here speaking at Star Trek. No, we got a lot of really cool stuff going on, and I'm really excited about it. In fact, Barret is giving this presentation at Star Trek. So a bit of a practice run for Barret to find out what works and what doesn't. Tickets, I think, are still available, though you will have to pick up your merchandise at the conference instead of having it mailed to you. So We have a number of interesting topics that we are looking at for the rest of the year. We have lightning talks coming up in July, so start thinking about that. If there's a short topic that you'd like to get up here and talk about, I'm thinking about doing some things maybe around home AI stuff or game development or things like that. We also have a couple of talks that we have under development that we are looking to firmly slot in. Alan is working on something with .NET Orleans. Marcel has some really interesting mad science stuff going on with Swashbuckle and Planet UML and just documentation generation for APIs. And we were talking to another person about either a talk on .NET Aspire, like Barrett's awesome talk last year, or a talk on Azure Functions. Show of hands, who would be interested in a talk on Azure Functions? Okay. Show of hands, who would be interested in a talk on .NET Aspire? Okay. So modest interest on both. That helps us as we are looking to plan our content. But that is much appreciated. Who here is hiring? Okay. Alan, you're hiring over at Improving? You're looking for software engineers?
All types.
All types?
Yep.
Barret, you're hiring over at CGI?
Yeah, CGI is always looking for experienced .NET developers. We don't really have any entry level, but if you're a mid to senior level .NET developer, we've always got openings, usually.
James, what you got?
We're looking for a senior engineer in .NET Stack.
So senior engineer in .NET Stack, we're at Foxen. Yeah.
I think Central has one software engineer. It's just not non-senior, just regular software engineer. So not necessarily entry level, but just mid-level, I guess.
And Central Insurance is looking for kind of a mid-level .NET developer. Drake.
Rogue is working for two senior one and one senior two .NET developers. Although we're sending out offers right now, so it's kind of like if people accept it, we're looking for less.
Okay.
So we're looking very actively.
So Road is looking for various .NET developers as well.
Yeah, senior and senior.
I have one that's probably not of too much interest to you all, but we over at Leading Edge are looking for more 1099 individuals, so contract opportunities, and particularly for Java developers for some upcoming projects. Yeah, so let's chat afterwards. But cool. And if you have any job openings, any hiring interests, things like that, put them in Discord, put them in LinkedIn group. That's a great place for those. House rules: be quiet. Unless you're asking questions, because Barret likes questions. And if you need a bathroom, Central's bathroom is down that hall over there. You can kind of wind over to the left a little bit. Yep. I think that's all I got. I'm going to turn things over to Barret for our talk, and as well as the HDMI.
Okay.
So there you
go.
I would, if you could.
You'll need to project on the VIA.
No. Helps if I select what I'm sharing. Okay.
Okay, we see VIA at the moment. Yeah, that's going to help people a lot. And I will get out of your space.
All right, we good on the YouTube? You're good? All right. Go ahead, start. All right, let's see here. So last year, I was giving a talk at a couple of conferences and user groups. It wasn't the talk that Matt was talking about. That one was actually on Aspire. But I was giving a talk on some of the new features that were in Entity Framework Core version 8 that came out last fall, or the fall before. Because actually it was version 9 that came out this past year. But as I was giving this talk, I was getting a bunch of feedback from people who were saying things like, wow, I didn't know Entity Framework could do that. as I was talking through some of these features. I didn't know Entity Framework, had all these cool things that I was talking about. And as I was thinking about that, it kind of dawned on me that maybe it was time for a reintroductory type talk, saying, Entity Framework has come a long way since the old version, and maybe it's time to reintroduce it to people and let them know what some of the things that are in there, what the improvements are, some of the differences between that and some of the other frameworks that are out there. So that's kind of the genesis of this talk. Just a little bit about me. My name is Barret. I am a Microsoft MVP in the business apps section, specifically for Power Automate. But I also like talking about .NET a lot, and also I do a lot of talks about soft skills as well. So, the rest of that you can read that about me there. So, Entity Framework historically, when you think about it, it had a lot of problems. The old version that was part of the old .NET, there were really no problems with Entity Framework, and I've got some things up here on the screen that you can kind of to go through. But there was a lot of overhead, there was a lot of performance issues. In the early versions, you couldn't write directly to SQL. It used this funky library called EDMX. There were some hidden behaviors that were problematic within it, and just it wasn't thread safe, and it was very heavily focused on code first development as opposed to database first development. That particular part really hasn't changed. It's still very heavily focused on code first development. But, and in fact, it's even more so nowadays than it was in the old version. But I think you'll find as I go through these, a lot of these other problems that you historically relate with Entity Framework aren't really the case anymore. It's really come a long way. So the first thing, we'll talk about a little bit about the historical bit of it. Back in 2015, 2016, when they were talking about redoing .NET from the ground up, and they were going to rewrite it, they were going to do it in public, they were going to make it open source for the most part. They decided, that was going to be a great time to redo Entity Framework as well. And so they came out, and obviously with version 1 of anything, there were a lot of problems, there were performance issues, there were a lot of features that were missing compared to Entity Framework Classic, as I like to call it. But as it's come through the years, and it's now up to version 9 now, the improvements are just stratospheric. It's come just a huge amount of way. But there are also a few things that are missing from Entity Framework Core as compared to it. But I think for the most part, you're not going to miss most of it. One of the things, EDMX is gone. That's never coming back. A lot of people hated that. The one thing that I do miss, yeah.
I did all of this. What was EDMX?
So EDMX was kind of this language on the back end that Entity Framework would use. It basically represented the file format that your database models would be saved in, I think, if I remember correctly. It's been a lot of years since I've messed with it. But if I remember right, that's basically what it was. It was just a specific file format. It was really hard to work with and caused problems. And that's gone now, yes. So,
it's not missed.
yeah, it's not missed, like a lot of things. But the one thing that I do miss is that in the old version of Entity Framework, there was a graphical editor that you could use to design your database and your entities. I do miss that a little bit. It was fun. But thankfully, there are a lot of third-party programs that let you do that nowadays. Database first design was a lot better supported in the old version. You'll find that in Entity Framework Core, you can still do database first design. You can take a database and you can scaffold it into a set of entities in your .NET. But it's a once and done kind of thing. You can't do incremental updates. So if you have to rescaffold it and maybe you've made some customizations to those entities, it'll destroy all that and rewrite it. So you can rescaffold from the beginning. Yes.
We run this issue, and what we do is all classes that generate by default are all partials. So we set a separate folder of just extensions to partials.
Yeah, and that is what a lot of people do is partials. So there, like he says, there are ways around it. By doing partials, you can do other things to help you to mitigate that loss of that. But for the most part, it's not really supported out of the box, so to speak. So, and I'm going to go through, as I go through this, I'm going to talk about a lot of these things that are up here, and this is just kind of a highlight of the things that we're going to talk about. But in addition to all these new features, the biggest advantage of .NET or of Entity Framework Core over The old versions of any framework is performance. It is monumentally faster. And you know, as people think about Entity Framework historically, and they compare it to some of the other ORMs and other frameworks that are out there, I think especially the most common comparison is Dapper. People will say, well, okay, I'm going to use Dapper because Dapper is a lot faster. That's not true anymore. You'll find as we're going through this, Entity Framework is, in almost every case now, virtually identical in performance to Dapper. So, and that's the first thing that I want to kind of go through here. So, first I want to compare it to the classic Entity Framework, and this is actually some statistics that I found online. This is comparing Entity Framework Core 3.1 to Entity Framework 6, which, you know, the last version of the classic version. And you'll find that even here in the third version of Entity Framework Core, performance was already 2 to 2.5 times better than Entity Framework Classic was. And it's, you know, we're up to version 9 now, and it's gotten even better. I couldn't find exact statistics, and I didn't have a chance to run some of my own, but I read a couple people anecdotally were saying it was as much as 8 or 9 times faster than Entity Framework Classic was.
With the error bug here, is it detecting errors, or how many errors it's producing?
That's error handling, the amount of time that it takes to handle an error when it does come up. So you can see here whether you're fetching 1 record or 10,000 records, it's a huge performance boost. And the same thing with making changes. You know, when you're sending data to the database, whether it's an add or an update or delete, it's incrementally faster here and even a lot better in the newer versions. But the other one, the one that everybody compares it to, is Dapper, because Dapper is considered to be lightweight. It's considered to be high performance. These statistics were actually off of Entity Framework Core 9, which was the newest version of Entity Framework Core, and doing head-to-head comparisons with Dapper. And this is on another website. You can see the link there. But you can see that in almost every single instance, it's on par. You know, it's within 1 or 2% of Dapper in performance. And whether you're getting the single record in various examples here, the only time that it's not is when you're using single with your LINQ query. You know, when you do .single. And the reason for that is, for some reason, Entity Framework Core does a take 2, so select take 2, or select top 2. So it's getting 2 records instead of 1. I don't know why it's written that way. I couldn't find anything in the documentation that explains why it does that. But that's the only reason that a single call is actually double the time as it would be in Dapper. So if you're using first, if you're using first or default, it's pretty much identical performance-wise. The same if you're getting mass amounts of records. You know, here's a test with 14,000 records. Comparison to Dapper, almost identical, no matter what you're doing. Whether you're doing a raw SQL query, which we'll talk about a little bit later, or whether you're doing LINQ, it's almost identical across the board with Dapper. And in fact, in this particular test that he ran, he found that the actual memory usage, Dapper was higher, which was one thing that kind of stuck out to me in this set of statistics. With inserts, again, it's the same thing. And actually, for inserting a single record, Entity Framework Core was faster than Dapper in his tests. So I found that kind of amazing. Because again, that's the classic argument of Entity Framework versus Dapper, is Dapper is so much faster. So again, with updates, pretty much the same thing. The biggest difference here with update is Entity Framework is still doing that change tracking, so it's going out and getting the record first. So it's doing a select first, and then it's doing the update. And that that accounts for that little bit of difference between that and Dapper. But even so, it's almost on par with Dapper. So yeah.
Just wondering real quick. So like, is Dapper supposed to be the competition in any framework?
It's generally, when you talk to most .NET developers and they're talking about how to get data to and from the database, the vast majority of them will either pick Entity Framework or they'll pick Dapper. There are a lot of other frameworks out there, but probably 90% of us are probably using one of those two when we set up a new project.
And it's kind of a different philosophy.
So what was that, Matt?
It's kind of a different philosophy.
Yeah.
A little bit more focused on people usually, and you have to more focused on objects.
Yeah. So, and you'll find most of the days it's now this ingrained choice that people historically have used one or the other, and so they stick with it. So, and that's one of the things that I'm trying to kind of to show people, that they don't need to just stick with it because of historical reasons now. And you know, there are still reasons to pick one over the other. So if you're dealing with huge, massive data sets where you're manipulating hundreds of thousands of records at a time, Dapper, that little incremental performance boost, Dapper's still a little bit better. If you want to get something which is really easy to get started with, LinkedIn is generally or not LinkedIn. Sorry, Entity Framework with LINQ is generally what people tend to prefer, just because it's a little bit easier to learn getting started with, because you don't have to understand SQL. As a developer, I kind of take issue with that, because I think that any developer who is working with data, which is almost every project you're going to be working on, needs to understand how that data is getting handled in the back end. They need to understand SQL. So there's a tendency for, especially with newer developers, to say, I don't need to learn SQL. I've got Entity Framework, or I've got whatever other ORM I'm using. But you really should. You need to understand how that works on the back end. So if performance isn't really the reason to choose one over the other, then why should I pick Entity Framework over Dapper, or why should I pick Entity Framework Core over Classic Entity Framework? And the reason really is the features that are available to you, and that's what we're going to start talking about. The first thing is that, like everything with .NET Core, Entity Framework Core is cross-platform. It goes everywhere. It works on Windows, it works on Linux, it works on Mac, it works on tvOS, it works on kiosks, it works on web TV, it works on Android, it works on iOS, it works on custom machines, it works on Android or Arduino, it works on Raspberry Pis, it works on WebAssembly on the front end in your browser. It goes everywhere that .NET Core goes, and that's pretty much everywhere nowadays. And it baffles me that a lot of people still don't grasp that concept that you can put .NET on .NET Core and everything that goes with it, including Entity Framework Core, on pretty much every device that's out there now. It works everywhere. So, excuse me, getting into some of the actual features now. The first one that I want to talk about is property value conversion. So let's say take this scenario where I have a character representing a character on TV, and that character might have a rank. Maybe it's a military character, you know, like Star Trek or Babylon 5 or whatever it might be. And I represent that list of ranks as enums in my .NET code. Well, you know, historically, whenever you're saving that to the database, it gets saved as the integer value of that enum. Well, property value conversions allow you to write a converter into your model that lets you save that as the string version. So I can look at my database data, and I don't have to think in my head, okay, 1 is captain, and 2 is sergeant, and 3 is supreme commander. I don't have to remember any of that stuff anymore, because Entity Framework Core will let me save it as that string value. So when I'm actually looking at the data in my database table, I can see those values, and it can convert it back and forth. And the way that you do that is you use this .hasConversion function that you add onto your model for that particular entity, and you pass in 2 parameters, which are both Lambda functions. So the first one says, okay, when I'm saving it to the database, this is how I want you to convert it. And the second one says, when I'm getting the value back from my database, how do I convert that back into my property? And by far the most common usage I've seen is in this particular scenario where you're converting enums to, or saving enum values. But you can create models that are property value converters that will convert it however you want to. I mean, you could save a float as the Roman numeral version if you felt like it. So that particular thing lets you do it. Yeah.
Find the use on a mapper to go from the name to the data object?
I have used it in the past. It's been a while though.
So what you're saying is it's not necessary just by using that?
Yeah, I mean, if you want your .NET entities to have one particular data type and you want your database to save it as a different data type, you can just put it right in your DB context in the model creating. And yeah, you don't need to worry about any of that kind of stuff anymore.
You gotta change a whole lot of stuff.
Excuse me. So that's the first one. The next one that I want to look at is entity constructors. So let's say you have a scenario where you want to have one constructor that's public in your .NET code, but when when somebody's instantiating a new object in your classes of a class, you use that public constructor. But let's say that you want Entity Framework to have its own constructor. You can do that. Historically, Entity Framework would use the public constructor and then would set each of the property values one at a time as it's pulling that data out of the database. Well, what you can do is you can set up a separate constructor, and as long as the parameters match the fields, the only difference is that on the parameters you're using camel case, and your fields have to use Pascal case. But as long as you set it up that way, Entity Framework will call that constructor instead. And it doesn't even have to represent all of them. So like the example I've got on here of my character class, I've only represented 3 in that private constructor. I've only represented 3 of the properties there. The fourth one, which is what rank, gets left out. So Entity Framework will still do it the old way. It'll call that constructor, it'll set those 3 properties, and then it'll set that final property on its own, the way that it used to do. And what this will let you do is you can have those 2 different kind of constructors. And that constructor can be private. So you can have a private constructor that only Entity Framework has access to. So that if you want to, for some reason, put in some logic when you're pulling something out of a database or your data store, if you want to have some different logic in there for some reason, you can do that now. And Entity Framework will just grab that and use that constructor instead. Now, the only big caveat to that is I mentioned, well, there's a couple of them. One, I mentioned the field names have to match the properties. Sorry, the parameters have to match the properties. And if you're using things like navigation elements in your entity, you can't have a private constructor. It has to be public or protected. So that's the one caveat with using a private constructor is it can't have any of those navigational properties in your entity. So that's the biggest thing to remember with that one. Now here's another classic example. A lot of times we inherit an old database of some sort that we can't do anything with. We can't change the schema. And a lot of those old database tables may have tables in them that have no keys, have no primary keys defined. And historically, Entity Framework really couldn't handle that in any good way. Well, now we've got this keyless entity type where you can put a keyless attribute on your entity, and Entity Framework can now load that table and now access it. The only thing that you have to remember with this one is that it cannot implement the change tracker logic that the Entity Framework has built in. It has to use, you have to come up with some other way if you need to make changes to it or keep track of the values. But it makes it very easy for you to pull in that data and maybe save that data back to those tables that don't have primary keys defined. Do you have a question? Or? That's fine, go ahead.
Okay, so let's just say, like, for example, like I'm a company and I'm currently like on Entity Framework version 6. How good is the transferability for Entity Framework version 6 to version 9?
Okay, so if you're going from the old Entity Framework, like version 6, or one of those previous versions, going to Entity Framework Core, it depends on the logic and the features that you've used as to how easy it is to upgrade that. The one thing is all of your .NET code has to be upgraded to .NET Core because Entity Framework Core needs that in order to operate. So that's the starting piece. But if you can handle that, it's generally not too big a headache in most cases to make use of Entity Framework. I mean, you could create a separate library that maybe your classic .NET application can access and put the new code in there. It's going to depend a lot on how you've structured the application and how many of those classic features that you've implemented that aren't really supported aren't supported in the same way in the new version, as to how easily, that'll speak to how easily your code can be updated. So.
He was also asking between versions within core, how backwards compatible.
Oh, like from one version of core to another version of core? As far as that goes, there's generally not any problems. Well, I should say after version 3. Because from versions 1 to 2 to 3, there were a number of breaking changes. So if you implemented some of those, you did have to go back and redo some stuff. But I think since version 3, it's been fairly stable. I can't speak to that entirely, but in my experience, my recollection, I don't think there have been too many that would cause problems.
Also mainly as keyless entity types, like you just mentioned, that like historically in the past, if I got this correct, that like basically there would be keys that were kind of difficult to access. So kind of.
Yeah, with keyless, it's more a case of tables that didn't have any keys at all. And in the past, any framework couldn't really deal with that very well. And this keyless, I think, was introduced in version 7, might have been 6, I don't remember. Another common example is if you have database tables that have a primary key defined, but then they also have a unique construct or a unique index or a unique table, or sorry, a unique field in that table. And a lot of times, depending on the database system that you're using, other tables can reference that unique constraint as a foreign key from another table. So any framework core now lets you make use of that the same way. So you can identify using the .has principal key in your model builder. And that'll let you say, hey, you can treat this other field just like a primary key as well. And there may be other tables that reference that as a foreign key. So that's something, again, in the past, Entity Framework Classic didn't really support that at all. And this is another one I think was introduced in version 7 of Entity Framework Core. So it comes in really handy. I mean, there's a lot of times in my own experience where I've had to basically write a whole different method of implementation in order to support that. But now with this alternate keys functionality, Entity Framework Core just basically supports it out of the box again. All you have to do is a little bit of configuration, and you're off and rolling. Let's see here. So the next one is shadow state properties. So sometimes there are situations where you have a field in the database table, but you don't want to include that field as part of your entity in the .NET classes. But maybe sometimes you still want to reference it. So by using the shadow state property, you can actually define that again in your model in your DB context. You can say, okay, this particular entity has this field in the database, but I don't want the entity to have access to it in the normal course of your .NET code. I don't want it to be really visible. So basically what it'll do is it'll take it into Entity Framework, keep it in the change tracker, and say, okay, you can reference it in a couple of different ways if you need to, but in your normal day-to-day working with that .NET code, it's not going to appear, it's not going to be visible. People aren't going to know about it unless they actually know that it's in there and represented. So what you would do is you do your DB, your context, say, if you want to reference it or make a change to it, say, db.entry, and you give it a reference to the object that you're working with, in this case, a character named Sinclair. You say, okay, I want to reference the property last updated, and I want to set the value to current date time. So that's one way you could do that. And then when you do your save changes back to the database, it'll save that change back to that field. Or again, you can use it just like anything else. You can use it in your where clauses. You can use it in your order by, just by referencing that ef.property, give it the type and reference the name, like in the last example there. And you can still make use of it in your code for those maybe one-off situations where you need to have a reference to it, but you don't want it to be there in the normal course of operations with that .NET.
Hey, Barret.
Yes?
Quick question. Do you know any of the more common use cases for shadow state properties?
I think it's the biggest one is maybe you have a field that you don't want. I mean, I haven't ever seen it actually used or implemented other than like test examples like this one. So yeah, do you have
I've got one from work. So
okay.
I'm super interested about it. I work in the hospital, so we have identifiers for a patient that we don't, in some cases, want to disclose to partners. So we have a pseudo key encrypted, well, not really encrypted, it's obfuscated,
Mm-hmm.
So that would be a perfect solution, right? You're keeping that, you're preserving your PII, what do you call it? Person identifiable information,
Yeah.
And then you can expose this pseudo key to your partner. So.
Oh, yeah, that's cool, then.
Right. Yeah. We don't want it anywhere. Yeah.
Yeah. So you still have access to it in the back end,
Yeah.
but anybody else that you're exposing it to won't see that PII. So that's a cool example. I like that.
Yeah.
In fact, I might update my example and use that, steal that for next week. So.
Thanks again.
Another common example is a lot of times you may have computed fields or other fields in your database that the database generates, your identity fields, things like that. And there's always been that key value or that key attribute that you could use for like the identity fields and let identity or let any framework know, hey, the database is going to take care of setting this value. But for these other fields like computed table fields, there haven't been a good way to tell any framework, hey, this is something that the database generates and you shouldn't mess with it. But now with this database generated annotation, you can identify that field in Entity Framework so that Entity Framework knows this is a field that's coming from the database. It gets set in the database. You don't need to do anything with it or mess with it. Just make it available for people to read. So it just adds a little bit more clarity to things like this is something I'm going to set in my .NET code. This is something the database sets.
One question.
Yeah.
Actually. So let's say that I had this example I ran into had a date and then a computed like year, month, day columns, and I'm trying to do an ND framework for mock database. Is there any way, like, is this something where it can actually emulate the behavior on the computation, or is it something where you're still manually adding things in?
No, you would have to come up with some way to mock that. Yeah, because it's basically telling any framework, don't do anything with this, ignore it, essentially, except other than reads. So, and you still have to implement that on, whether it's in your model or in the actual backend of the database. You still have to tell where that's coming from, how it's being generated, that kind of thing.
Yeah, I was just wondering if we had a date value and then we had breaking out the database and just mocking it. It worked out, yeah.
Yeah. There is one thing that I will point out at the end here is that one of the things that is supported in Entity Framework Core now is in-memory databases.
Yeah, that's what we do.
So you can do it that way and mock it that way. It's not generally recommended for production, but you can use it for like using it for like your user unit tests, things like that.
That's what we use just because a lot of our business logic is the query logic. So if we want to test it in our memory database, it's really helpful.
Yeah, that's always been one of my biggest concerns with things like mock is I'm not actually giving it real data most of the time that might come from my database. I'm imagining what it might be. So when I'm doing unit tests, that's always been a struggle for me. So. All right, so the next one is really fun. This is global query filters. So another very common use case is things like multi-tenancy or like soft deletes, where if you have like an is deleted column and you want to ignore anything that's flagged as deleted when you're doing most of your queries, you can set this up using global query filters in your Entity Framework now. So what you would do is you go into your DB context class, and as you're defining the entities, you can add this .hasQuery filter. And you can either set it globally, you can use, like maybe in this example here, I've created this universe service where I can pass in what my query filter is going to be based off of, in this case, the universe. So an example for this is like, say you have a single backend API that supports multiple front-end database or multiple front-end websites. And maybe one website is for Babylon 5, one's for Star Wars, one's for Star Trek. But you want them all to be handled by a single API in the backend and a single database. Well, it's a good example for things like multi-tenancy and things like that. Whereas you can have this service saying, okay, when a request comes in from my Babylon 5 site, pass that into my database context. When it's coming from the Star Wars site, pass that into my database context. And it can apply that filter saying, okay, only give me the records that are tied to this particular genre or this particular universe. And do the same thing with the is deleted, say, okay, give me everything that's not deleted. The biggest caveat with this one is that it only works on the top tier entities. You can only apply to top tier entities in a hierarchy. So if I've got like my characters table and my seasons table, and they both reference the episodes table, so I've got a list of episodes in a season, I've got a list of characters that have earned certain episodes, then my episodes table can't have a query filter applied to it. Only those top two query keys can. So, but as long as you're keeping that in mind, it's fairly easy to implement and work with, and it's a great way of implementing that partitioning of environments.
So how's the injection police not all? Is this something that we can just bypass with some injection here?
Well, I mean, in this particular case, because you're putting it in your DB context, you would have to inject a service class of some sort in order to pass in what that parameter is going to be. So there is going to be injection that you're going to have to use in order to make it work.
But I can't like do some logic stuff.
I mean, it's not. I mean, as long as you're writing it in such a way as that the user's not passing in what that filter is going to be, and whereas like the services. So basically, like in my example with the API, the service is identifying this is coming from this website, this is coming from this website. So on those queries, I want to apply that filter to it. But yeah, you would have to be careful on how you wrote it, so that to avoid like you're talking about like SQL injection kind of thing.
Yeah, like I'm assuming kind of like that generic or whatever the characters protecting a little bit. That's about it.
Well, with MD framework in general, doesn't it defend against the most basic SQL injection? Like if you have, I don't know, dash, well, the standard SQL injection is make it into a comment, do the next thing. I think that VF Core has that kind of built-in invalidation of any string.
It does protect you from a lot of stuff, but yeah.
Like all the basics.
Yeah, nothing is going to protect you from an idiot developer, though.
Yeah,
it's one of my favorite things. But just a couple more examples here, like for like the is deleted, so like the soft delete kind of thing. So you're saying, in most cases, for most queries, I want you to ignore anything that's flagged as deleted. But then there are, say, I've got this admin site then that I want to be able to use to maintain all of this in the back end. Then it gives you this filter or this command that you can add to your query, your LINQ queries. That's the .ignore query filters. So if you need to ignore that globally set query filter, you can just pass that in with the parameter or with the LINQ query that you write, and it will ignore that and just use whatever it is you add to your LINQ query. So if you need to override it, there is a really easy way to do that as well. So.
Question.
Yeah, somebody?
Have you seen this like used in production heavily? Because what I'm picturing is like that model builder class would have just tons of.
Not in anything that I've done. I have talked to people that have used it for multi-tenancy sites, especially. I have suggested that we use it for the project that I've been working on for soft deletes, but nobody seems to want to put in the hours that it would take to go back, because we're like 2 years into our project, so nobody wants to go back and put in the logic and all the code that would need to be supporting that for something that wasn't added from the ground up. So obviously it's a lot harder in that case. But I have talked to people that have used it, and they said that it works really well. All right. Any other questions on that before I go on? Okay. All right. So raw SQL. This was one of the common arguments of Dapper versus Entity Framework way back in the beginning days, is that Dapper lets you write, or actually it requires you to write the raw SQL because that's the only way Dapper works, whereas Entity Framework didn't. It hid all that from you. Well, that hasn't been true for a long time. Entity Framework, even the classic versions, 4, 5, and 6. Before Entity Framework Core came along, lets you write those raw SQL queries. But one of the things that Entity Framework Core has done is it's basically, it's done that, it supports that fully, it's very performant, it works really well, but it's taken it to the next level now so that you can combine raw SQL with your LINQ queries now. So you can start with a raw SQL, say, okay, I'm going to do my select star from characters, pass that in, and then you can add LINQ commands onto that. Say, okay, after that, I want to filter it by this. I want to order it in this particular way. I want to include the subtable. So it's basically taking that ability to work with the raw SQL and just taking it to the next level. So it combines the best of both worlds. And it works really well. This is something I have used a couple of cases. The one place where it works the best is with stored procedures. So, with any framework core, in order to call stored procedure, you have to use that raw SQL for the most part. But then getting the results back from that, then I can apply a LINQ query to that, and that just works. It works pretty well. So it's perhaps not quite as performant as maybe writing it all yourself in raw SQL, but it makes it a lot easier to deal with. So statement batching, this is something where it's basically, this is one of those incremental things, but there's also another one where it's taken to the next level. So statement batching is basically, if you have an example where I've got my characters table here in my first example, and I want to change the race on all of them to human. If I have 500 characters in that table, that's going to be 1,000 entity framework calls to the database because it's doing 500 selects, and it's doing 500 update calls. With Entity Framework Core, well, it's still 1,000 calls. So it's still going to do those 500 selects and 500 updates. It's Entity Framework Core has improved how it batches those groups. So it might say I'm going to send 40 at a time, or I'm going to send 100 at a time to the database and get those results back. So there has been some improvement there, but where it has again kind of taken it to the next level is with version 7, it's introduced these two commands, execute update and execute delete, and the async versions of these, which basically is saying instead of doing those normal 1,000 calls, so my 500 selects, my 500 updates, I'm going to do one update statement and say, okay, just do update characters, set race equals human, and go. So it's making that one call by doing this. And the way that it does that is by bypassing the whole change tracker stuff that Entity Framework normally does. So it won't do any of that logic, but it'll just make that one update call. So
to clarify, you don't need to call like save changes.
No, with the execute update and execute delete, you don't need to do save changes. It's a one and done. The next thing it does, so DB contexts are of themselves, they're fairly lightweight. They don't occupy a whole lot of memory most of the time. The real cost of a DB context comes with that initial instantiation, what's being created. So whatever you're doing in your logic to create that DB context, it may be minor, it may be a whole lot of stuff that you're doing to get that up and running. And for each of these, flows that are coming in from your API or whatever it is that's calling into Entity Framework, it's having to do that over and over and over again. So incrementally, that costs you a lot over time because it's having to go through that whole process of creating it, and then when it's done with that workflow, it sends it off to the garbage collection and it's gone. Well, with DB context pooling, it's saying, okay, when I'm done using it for this particular go-around, I'm going to save that DB context instance in memory, basically turning it into a singleton in your application. And say, I'm going to save that, and then the next call that comes in, I'm going to reuse this DB context that already exists. And that saves you all of that on-configuring stuff that you were doing to set up your DB context. By default, if you're using this add DB context pool, if you don't pass an additional parameter, it'll create up to 1,024 instances and save those in memory. But you can set that value if you want it to be higher or lower. So the biggest advantage here is there's one big advantage is obviously you're saving that spin up time. The biggest caveat with that is if you're doing anything in your DB context around like state management or keeping track of any information in your context for some reason, that information gets saved. So if we go back to our multi-tenancy example, if a particular context was created for my Babylon 5 website, the next time it gets, if you're not careful in how you write that, the next time it goes and gets that instance, it's still going to be tied to your Babylon 5 context. So depending on how you wrote it. So you have to be careful with how you write that kind of thing with multi-tenancy or anything else where you're saving state related in the context. So as long as you're careful with that, then this is a really good way of working with us and saving you that incremental improvements over and over to help you out. And it's important to remember this is not the same thing as database connection pooling. So if you want to make use of that, you still have to set that up separately. So yeah. So DB context pooling is saving the entity framework object and how that interacts with things. Database pooling is when it's making connections from your application to the database server. There's a certain amount of setup that's involved in that as well, and that's your database connection. So with database connection pooling, it's basically the same idea as it's saving those existing database connection objects. It's basically staying connected to the database instead of disconnecting at the end of the work that it's doing.
So basically, the difference is between an application that sounds to me like more physical in terms of like just.
Yeah, you could think of it that way. So you could think of the DB context pooling as being what's in the application, and the database connection pooling is your physical connection from your application server to your database server.
Okay. Sorry.
No, that's fine. So kind of getting into a couple of things that I brought up with my EF Core 8 talk last year. One of them is complex types. So there's a common example where you want to design something a certain way in your .NET entities. In this particular case, I've got a customer, and that customer has an address. And if that relationship between your .NET objects is a one-to-one relationship, Entity Framework Core now gives you this idea of complex types. So in the past with Entity Framework, when it goes to save that to the database, you're going to have a customer table, you're going to have an address table, and they're going to be separate tables that are going to have like a primary key, foreign key relationship. But with complex types, if you've got this one-to-one relationship in your .NET objects, but you don't want them to be in the same class, you can define the child essentially as a complex type, and it will save it in the same database table. And basically the way that it does that is by prefixing those fields with the name of that class. So in this particular case with the address, it's saying address underscore city, address underscore state, and so on. So they're all being saved into that same database table. So on the back end, they're all together. But in your .NET code, you're still keeping them as separate objects. And any framework will just handle that when it's going back and forth from the database. You don't have to do anything to set that up. So yeah, your question?
We're generally writing the SQL first and then doing the something wizard. The wizard generates the F4.
Mm-hmm.
Would it be able to read that and know it's complex type?
I don't believe so, but I have never tried it, so I don't know for sure.
Does complex type, you have to specify this one-to-one, or is that?
If you identify something as a complex type, it by definition is a one-to-one relationship. It can't be a multiple. It can't be a one-to-many. A complex type has to be a one-to-one relationship with the parent class. But you can nest the complex type. So if I have my customer, and that customer has an address, and maybe that address I want to have another object that's like geocoordinates, with like latitude and longitude, you can nest that as a complex type underneath the complex type. And when it goes to the database, it will be, if I call it geocoordinates, it'll be like address underscore geocoordinates underscore latitude address underscore, I might have this backwards, but it'll add an additional prefix for each down the hierarchy that you go. And still save them all in the same database table in the database.
I assume it's pretty limited to like non-super complex. Like if you put like a list of addresses, it would probably just.
Yeah, you can't do it as a list because it has to be that one-to-one relationship.
Okay. Oh, right.
So yeah, in this particular case, you're probably not going to do customer and address because the customer might have multiple addresses. But that's just the one example that I had as part of that. So, but it gives you the idea of how that would work. But yeah, it does have to be that one-to-one relationship though. So, but that actually kind of was there another question? Okay, that kind of leads on to the next topic, which if you have in your class a list of a primitive type, so like an integer, a float, a GUID, you can, or actually Entity Framework by default now, will store those in a string table or a string field in that database table. It won't do it as a child table. It'll actually put them in there as JSON, a JSON array of those objects. So in this particular case, I've got a customer with a list of GUIDs that are my wish list items. It will save that into a single field in the database table, and we'll store that in there as text as a list of array, or a array of objects there.
So like autosave.
I'm sorry, what was it?
So like autosave, right?
Kind of, yeah.
So would that like be recoverable? Like if there was like a mistake made, you like want to go back, like
Oh, okay. No, I think I misunderstood what you said. No, it's
just concatenating.
yeah.
So like if we had names instead of, it would literally just be like Drake, Smith, Bob, like Drake, comma, Smith, comma, and just add them all together, one JSON object.
Gotcha.
Well, it in this particular example, it won't because it only works with primitive types.
Oh, is it a string primitive?
No.
Oh.
String is a complex type.
Sorry, they were characters.
Yeah, character, yes. If you had a list of characters, it would save it that way. Which is funny because a string is a list of characters. So there's a couple examples. You know, you can, even though it's saving it as a single field in the database table, you can still use your LINQ against that, just like you would treating it like any list of objects. And the way that it does that is by using OpenJSON when it's making that query out to your database server. So because it's storing it as JSON, it can use that OpenJSON functionality that SQL Server has, SQLite, Postgres. I don't think all of the database systems do, but I think most of them do now. Compiled queries, this is one where you can kind of get a little bit of incremental improvement. So obviously, with Entity Framework, the first time that a particular query is generated, Entity Framework has to compile that query into a SQL statement of some sort. What you can do is now you can define that as a compiled query with that ef.compileAsync query, and basically pass it in as a Lambda function or define it as a named function, either one. And what it will do is instead of doing it as part of your just-in-time compiler when it's running, it will actually pre-compile that as part of the build. So you're just getting, again, it's not a huge improvement, as you can see from the statistics that I've got in there, but every little bit counts. If you're doing thousands of different queries, you know, that all adds up over time. So so if you've got something there, you can set it up as a compiled query and just get that little bit of performance boost.
What's the downside? I assume the downside would be more RAM from the application and more upfront memory, or?
Yeah, it's going to use more memory ahead of time, but you know, it's not anything that you wouldn't already have if the application's been running for a little while and it's got this list of compiled queries that things that run. So yeah, it's.
Then does it only really benefit the first couple times using it after you build, or does it? So I have an application that has a fairly complex query that's used, but only like a couple times a day.
Yeah.
Would this be a use case for that? If it's maybe
It might be. I mean, as you can see from like the memory of the last column there, it's not a huge improvement as far as the memory allocation goes.
What's more speed? I think it takes 750 milliseconds.
Yeah, and these are actually these examples, it's microseconds.
I know.
But,
Yeah.
But yeah.
That's why we want it to be faster.
So yeah. So like I say, you know, it's not a huge improvement like some of the stuff that I've been talking about, but you know, every little bit. Again, if you're trying to eke out every bit of performance boost that you can get out of your application. So just kind of the last few things that I want to cover here. There's a few other features here that I didn't want to go into too deeply. There's things like field mapping. So if you've got things like WPF and Xamarin, which use that I notified property change statement, one of the problems with Entity Framework is that when it does that initial setup of a page and it's putting those values in there, it's already flagging it as dirty, each of those fields, and that causes problems with Entity Framework. Well, now with field mapping and the what you have to do to support that is a little bit complicated. That's why I didn't put an example of here. But it is in there now so that you can implement that and you can override that so it's going in there not thinking that those already need to be saved back to the database. So there's full support for nullable reference types. The documentation still calls them new, but you know, nullable reference types have been around for a little while in .NET Core. There's eager loading for derived types now. So when you've got like a dot include or a dot then include, if you have, for instance, like a derived type, there might be a student as a type of person or whatever it might be. There's full support for that now, which wasn't well supported in any framework in the past. There is improvements in efficiency for await for each examples. There were some issues in some of the early versions where this might cause it to go into a death spiral and just keep looping over and over again, or it might get stuck in a loop with the way async works. In this, that's all been fixed and made much faster. I mentioned earlier there's support for more data sources. There's Cosmos DB now. There's in-memory databases. Again, they don't recommend in-memory for production environments, but it is there as an option if you want to use that for like unit testing or some other development work. And God help you, there's even support for JET into Microsoft Access now. So
Never die.
if you are somebody that has to deal with that, I feel sorry for you, and I wish you well in your new career path as a teacher or whatever.
Is T-SQL supported as well?
What's that?
T-SQL is supported. T-SQL, like SQL Server.
Yes, yeah. There's and then of course there's full support for all the new JSON stuff, document DB, all that's out there. So, so kind of bringing that all back together. So, I mentioned at the beginning that the historical argument has always been between Dapper and any framework, and it's always been, well, one of them's more performant, the other one's easier to use. Whatever it might be, whatever the arguments might have been in the past, really those arguments really have no place anymore. It's a matter of being able to do what you want to do with a database and with the data that's in there. And Entity Framework, yeah, sure, you could write all of your custom SQL with Dapper and do it that way if you want to, but Entity Framework makes a lot of that a lot easier now, and it's got a lot of other features that just give you that next tier improvement over a lot of the other options that are out there and available to you. So, you know, if it's been a while, it's time to give Entity Framework another look. Thank you. So if you want to reach out to me, there's my personal website on there. I'm on LinkedIn as Barret Blake, and my Blue Sky handle is on there as well, barrettblake.dev. I do not use Twitter anymore, and I will not call it X.
Same.
So, I tried Mastodon for a while, but there's nobody there, so I just kind of gave up on that. So.
Last questions?
Yeah, any questions? Yeah.
All right. You can tell how much I've spent on ND Framework for the last year. You were saying that for stored procs that you had to put in actually like straight PC for SQL. We've been using stored procedures with models in ND Framework without needing to write any SQL.
Okay.
I wasn't the person to set it up though, so I don't remember how they did it. Because if you do the auto generate from an existing SQL proc, it'll actually generate essentially an empty class for the result in the entrance, but you can actually then populate the result, and ND Framework can just write straight to a C# class for your result, and I believe also for your parameters.
I'm gonna have to look into that because I haven't spent a lot of time with using raw SQL, and every time I've called a store procedure, I've always done it using the raw SQL call. So
you can use ND Framework, and that's where we had to use the extensions because the default, if you're having a you have a T-SQL stored proc that is giving you a table back. By default, ND Framework generation tools will just give you like an empty class, but you just extend the partial. We wrote our class in that, and it was able to just read that as the result just fine.
That's very cool. I'm gonna have to look at that and maybe revise it a little bit here.
Softball question for you. Some of the folks who are averse to EF think it has poor performance. You showed the performance was good here. Are there any common tricks that you should be aware of when you're trying to optimize your queries, thinking specifically like as no tracking and anything like that?
Yeah, that's a good example too, and I didn't include that, but especially with that kind of thing, if you have a situation where you want to pull some data in, but you know you're not going to update it, you should always use things like as no tracking, so it turns off the change tracking for that, because that'll give you not only speed boost, but it'll also give you a lot better memory usage as well. So
it'll give you a lot less errors in trying to access this database multiple times.
That too. So we actually had one where this is an example from our own project that I'm working on that I've been trying to solve recently. Is for whatever reason, somebody had written the code where it was iterating through this list of entities and checking to see, okay, have there been any updates to this for some reason? Do I need to update? Because the data was actually stored in 2 different places. So I was looking at this and say, were there any changes between this and this? And if so, then I need to update this other one. And for whatever reason, they were setting this to reset the change tracking in Entity Framework with each iteration as it was going through. And it was turning what should have been maybe 2 database calls into like 800 database calls. Just because they were resetting the change tracking. I don't know why they were doing it. But then they were coming to us because this just went into production a couple weeks ago, or about a month ago now. And they were screaming about the load on the database because this process runs like every 10 minutes to check this data sync. And yeah, and that was one of the first things that I discovered. It's something somebody written about 18 months ago. And yeah, I'm in the process of ripping that out and just replacing it with this as no tracking because I know that the entities coming from this place aren't going to change because these are the source of truth. And it's only over here that I need to make those updates. Kind of wild. You get some fun.
For performance, how is the performance versus stored procs? We have a bunch of legacy 1 to 3,000 line P-SQL stored procs, and we were looking at trying to bring them up because it's very hard to unit test stored procs like that. How is the performance versus? I mean, that's been the argument we've been having is, well, we shouldn't bring it forward because Entity Framework's not performant compared to P-SQL for large queries, or the difficulty. So any advice there?
As far as performance, I think you're actually probably going to get better performance out of Entity Framework. I don't have any data to support that. The biggest caveat there, especially with with the large stored procedure, is you've got to rewrite all that as .NET code, and that's not something that I've had to do. It's always been something where a particular client or a particular project I was working on, they either had one or the other, and they said this is what you're going to use, so you have to use it because clients always know best, right?
Always. 100%.
Clients are smart.
But they do need help.
Okay, this is recorded, so yes, clients are very smart. They're fantastic. They're awesome. They know everything, so, even when they don't. I got to say it that way for the recording.
If a client hires you to be an expert, it's because they're already an expert.
Exactly.
They never hire you to be an expert because they're not an expert.
We all need a little help.
Maybe a little extra help taking 5 minutes out of the live stream.
Any other questions?
All right.
Thank you, everybody.
Thank you.